Welcome everyone. We're jumping right into today's explainer on a topic that literally impacts every single physical space we occupy: proper chemical dilution. We obsess over the types of chemicals we use, but the exact ratio of water to chemical, well, it isn't just a casual suggestion, it's the absolute bedrock of safety and hygiene. So be perfectly honest with yourself for a second. Have you ever considered adding just a little less chemical to try and stretch your budget? Or, on the flip side, maybe adding a bit more, hoping to speed up a really tough job? It's such a common temptation to just eyeball it. Now, sometimes you actually can reduce chemicals. For instance, switching from regular wipes to microfiber wipes can safely reduce your chemical needs by about 50% for a similar clean. But unless you're fundamentally changing your tools like that, these perceived shortcuts, they're setting you up for massive failures. To really grasp why, it helps to look at this like a giant spectrum. We're dealing with two opposites, but equally dangerous extremes of improper dilution here. On one end, you've got way too much water, and on the other end, way too much chemical. Wandering away from the exact center leads us directly into two very distinct types of danger. Let's start with Section 1, the weak solution trap, or the dangers of dilution deficits. Okay, so what actually happens when you use too much water and too little chemical? The resulting solution isn't just ineffective, it's actively dangerous. You are completely stripping the solution of its engineered cleaning power. Now, with standard detergents, this usually just means a drop in cleaning performance, or you're wasting your time. But when we're talking about disinfectants, that's when a weak dilution becomes a serious hidden hazard. Why does a weak solution fail so spectacularly? Because sublethal doses of sanitizers or disinfectants don't actually kill the germs. Instead, they allow surviving microbes to build up a resistance to that specific chemical. Those germs then spread throughout your facility, and because they're now resistant, they'll survive even subsequent cleanings that are mixed properly. In high-risk areas like healthcare facilities, this isn't just a theory, it's a documented, life-threatening infection control risk. Which brings us to Section 2. The toxic overdose danger and the risks of chemical overload. We absolutely need to debunk the myth that more is better. I get it. It's human nature to think pouring in a lot of chemical will clean faster and harder. But the facts are super clear here. Too much chemical and not enough water does not speed up the procedure, and it guarantees absolutely no better cleaning performance. Literally all it does is dramatically increase your cleaning costs while introducing totally unforced risks into your environment. The collateral damage we see here is severe. First off, that heavily concentrated mix becomes highly toxic. Second, it becomes incredibly dangerous to the user. Things like fumes and skin contact become really serious threats. This is exactly why safety data sheets, or SDS, legally mandate dilution ratios. In places like South Africa, for example, having these SDS readily available on commercial sites is a strict, non-negotiable health and safety regulation. And finally, chemical overload is harmful to the surface itself. You're actively degrading the very facility assets you're trying to maintain. Let's move on to Section 3, the safe cleaning standard, finding that optimal center. Proper chemical dilution is absolutely critical to a safe and effective cleaning procedure. I really want you to notice those two words together, safe and effective. You just can't have one without the other, and you definitely can't achieve either if you're just guessing. There is zero room for guesswork if you want a facility procedure that works exactly as intended without harming anyone. That logic leads us to this definitive golden rule. Always follow the manufacturer's guidelines as listed. Those labels are the result of rigorous scientific testing. And here's a critical pro tip for you. While recommended dilution ratios are often printed right there on the chemical containers, sometimes they aren't. If they're missing, those exact ratios must be specified on the product's safety data sheet. Find the data, trust the science, and guarantee the product performs exactly how it was engineered to. As we wrap up this explainer, I want to leave you with a final thought to mull over. Is your current chemical dilution protecting your facility, or is it actually compromising it? Are you risking a dilution deficit that breeds life-threatening resistant germs? Or maybe a chemical overload that's just burning through your budget and damaging surfaces? Remember, knowledge is only power when it's applied. Go check your safety data sheets, scientifically monitor those high-risk areas, and ensure your cleaning procedures are truly keeping your environment safe. Thanks so much for joining me to break this down today.